Welcome back to Paleo Talks. Good to have everybody out there joining us. We see we have a lot of guests from across the world, so that's exciting. And today we're going to talk about something we've never talked about, anything even close to this, have we, Chris?
No, not at all.
No, it's very interesting. And so our special guest this week is Peter Kloess with us from Berkeley. Good to see you.
Yeah, good to see all of you. Thank you very much for having me for this.
Now, this is really great. I was out on a walk listening to Science Friday, and that's where I heard your interview. And I was just thinking, I wonder if he might have the time to be on our show, because that was just really great work. That was great.
Yeah, thank you. And yeah, just kind of came out of the blue. They emailed me, and yeah, we just made it happen.
And you were telling me you actually had to make like a box or something to put yourself in for sound control wherever you were.
Yeah. So as part of like the pre-interview process before we actually do the taping, I was chatting with one of the producers, and she was saying, "Oh, we're getting a lot of like reverb and echo." So basically, I created a cardboard box fort and threw a blanket over top of that. So I was completely covered. And I mean, I really was hunching over at talking on this headset. And she's like, "Oh, that's so much better. Keep doing that." So for the entire interview, I was kind of in a fort doing this.
We should add that to the visual side as well. That would be All right, so yeah, the topic today is going to be about these enormous birds. But before we get to that, let's head over to David, who will remind everybody how the show works.
Thanks, Blaine, and hello, everyone. Welcome back to Paleo Talks. Thanks for joining us again, and if you're new, welcome. Thanks for joining us for the first time. The way Paleo Talks works is we're going to start off with chatter like this, and then get into our guest presentation. And after the guest presentation, the rest of the program is going to be Q&A with questions from our panelists, but also from the audience. So once Peter's done with the presentation, I'm going to remind everybody to go ahead and leave questions in the comments of the Facebook video, and we'll be reading those out afterwards. And as always, if for any reason you can't leave a comment on the Facebook video, I'll be keeping an eye on the Gray Fossil site, Twitter and Instagram pages, so you can send us your questions over there as well.
All right, thank you, David. So there's all kinds of ways you can get in contact with us, particularly David, to ask questions. And let's move forward. I want to remind everybody that we're coming to you from the Center of Excellence in Paleontology at East Tennessee State University, and we oversee the research at the Gray Fossil site and a lot of other research as well, though none of us work on birds like Peter does. And so we're really excited to jump into this and start hearing about these birds and how all of this got going. But before we do that, we like to start off with just how in the world did you get into paleontology, Peter? You could tell us your story.
Sure. Yeah, so I grew up in San Francisco, in the city, not too far from the beach and from the zoo, for anybody that's familiar with those landmarks. Yeah, and just as a kid, my parents read dinosaur books to me. I think a lot of us as kids, dinosaurs are kind of that gateway drug, if you will, to science, and that was definitely the case for me. I think I've heard many stories from family friends that when I was 5, people asked me what I wanted to do, and I said paleontologist. And I stuck with it. I took as many science classes as I could, filled my summers with science camps, and eventually, after high school, got myself to Montana State University at Bozeman, where they do tons of dinosaur paleontology. The Museum of the Rockies is there. So during that 4-year stint that I was there, I was taking all the courses, but I was also supplementing my time volunteering at the museum, as well as going out on dinosaur digs for like multiple months at a time over the summer. So just right from the bachelor's degree, I was diving headlong into paleontology. but then I had to step back a little bit, just step away from academia, and it what was originally intended just as a couple years away, before returning for my master's, ended up being a decade. And so I took a lot of time away from the academic side of things. I worked for a nonprofit for a couple years, but the majority of that decade I was working in the environmental consulting realm. And so like the easy explainer on what I was doing within environmental consulting is I tell people that I was saving fossils from bulldozers, construction sites, even pre-construction, surveying plots of land, trying to look for fossils, understand what sort of hazards may pop up while construction is going on. It was that sort of thing. And during that time, I traveled a lot of the Western US. I mean, I think in 1 year's time, I worked pretty much every state from like the Dakotas to California, if you drew a straight line from those states. And that was a very busy year.
You saved a lot of fossils.
Yeah. I mean, I think we did. I mean, that's the thing, is that you have the Environmental Protection Act, and in California we throw on top the California Environmental Quality Act, and so all of these laws state that these are non-renewable resources that need to be protected, and they need to go to repositories. So that's where depending on the state, they could go to like the Denver Museum if it was Colorado. They could go to the LA Natural History Museum if it's in that part of Southern California. So yeah, we would get these fossils, crate them up as quick as we can so construction can keep going. And then at that point, they just get shuttled off to a museum, and we never got to see them again. And funny enough that I say that, I mean, that was part of the impetus for coming back to academia. I had a great time doing the mitigation, saving these fossils, and recognizing like, hey, I'm doing a good thing for science and for knowledge, world knowledge. But there was always that curiosity of, well, what happens next? What does that fossil represent? Give me some more of the context. I want to know more. And as consultants, we only go so far with those line of questions.
I think that perspective is something a lot of students need. So.
Yeah. And I mean, I was having a conversation just like a week ago about science broadly. And I think just at the core of it, it's curiosity, just being able to ask questions, and then layer on top of that, the willingness to see it forward, to try and answer those questions. I mean, yeah, I think science just at its core, that's as easy as it is.
So you went back and you did your master's, and now you're working on your PhD. So how did your research focus change from dinosaurs to what you're working on now?
Right. So I think definitely the transition was in the master's. So my master's, I worked on seabirds at Cal State Fullerton. So this is Southern California. And I think it kind of all comes back to being that kid walking the beach and seeing seagulls and pelicans just flying around.
Fantastic.
Yeah. So as we recognize that birds are dinosaurs, in some ways I didn't stray that far away from the dinosaur interest. Just maybe a little bit more contemporary.
Right. Well, that's great.
Yeah.
Well, we better get on to looking at the first slide. So if you could go ahead and move in that direction, and if there was anything else you wanted to add in there with your sort of background story, go ahead and do that too.
Oh yeah, no, this is the perfect transition to talk about the research that my colleagues and I had that came out just last October. So here in this slide, this really is, it's funny to encapsulate an entire master's in one slide, but that's essentially what I'm trying to do here. So for my master's, I assembled a data set of over 500 seabird fossils from along coastal California. So this map here on the left, you can see all the dots represent localities or generalized localities from Sonoma at the north end all the way down to Baja in the south end. And with this data set of over 500 specimens, I was trying to understand how the seabird community was changing over approximately 12 million years of Earth history. So tons of fossils to look at. The big takeaways that I'm showing here on the right-hand side is birds like these sulids and procelarids at the bottom. These are things like gannets and boobies and shearwaters. From the middle Miocene to the earliest Pliocene, those birds are declining in numbers. And the alcids, kind of in the middle of the screen, these are things like auks and murres and mancallines. They were on the rise in that period. In that paper, we talked about the various biases that leads to that pattern. But ultimately, my advisor and I, we felt that it was really due to upwelling patterns changing as a result of tectonic shifting. So that's the master's in a nutshell, focused on seabirds. And as part of that master's, that data set, I was visiting multiple museums, and in particular, one of them was the Santa Barbara Museum of Natural History. For those of you that aren't familiar with where Santa Barbara is, you have a map here on the right showing San Francisco and Los Angeles to give you that frame of reference for where Santa Barbara is. So there were quite a few fossils here at Santa Barbara. And then one very special one, very near and dear to my heart, is this one. So this is a slab and counter slab that are displayed in this is in the exhibit hall, mounted to a wall. And just to give everybody the background on what a slab and counter slab is, I kind of think of it like if you've ever pressed a flower in a book, you squish it together in a book and you peel those pages open, you're going to have some of the flower kind of stuck to both sides of the book. And ultimately what we see here in that same vein, a large Pelagornithid died and was buried by sediment. And when it was uncovered, they unpeeled the sides of that rock in such a fashion that the bird was encased in both the left and right side of this of these slabs. So this is an amazing specimen to have on display, and unfortunately, I don't get to name it. It's already been named, so that's what I'm showing here with this title. Hildegard Howard is a famous avian paleontologist. She worked for the Natural History Museum in Los Angeles County, and she described the specimen, naming it Pelagornis ori. Well, I guess Osteodontornis ori, and then it has subsequently been named to Pelagornis in 1957.
So with something called gigantic, we want to know how gigantic.
Yeah. So in this case, this Pelagornis ori, I think, is clocking in somewhere in that 4 to 5 meter wingspan. So for those of us non-metric folks, that's like 12 to 15 feet. So pretty large, but these birds do get larger, and I'll show those to you in a second. But this is definitely a big one. And something I forgot to point out in that title, not only did it say gigantic, but it did say toothed with the quotes on it. And this is a zoom in here of the jaw from the left-hand slab. And so it may be a little difficult to see the pseudo-teeth And at which point here, if I point them out with arrows, you can start to see those little tiny bumps and ridges along that bone that's kind of trending from bottom left to top right. Okay.
So just to clarify with people out there, birds don't have teeth today, right?
They do not. No. The last toothed birds, like let's just say the last toothed birds were from the Mesozoic, before the Cretaceous extinction. And so for this group to have these projections, that is something special. And just to clarify, when we talk about teeth, and if you look in the mirror as you're brushing your teeth, the teeth that we all have, these are made of enamel and dentin. That's the components that we see in teeth across all sorts of organisms. These teeth, and I'm going to say air quote teeth for these birds, these are not made of enamel and dentin. These are strictly bone, and they are coming straight out of the jaw. So that's where they look like teeth, but we can't call them proper teeth. And funny enough, I mean, here's my next slide. So here we have, these are images of pseudo-teeth. These images are not from that Santa Barbara specimen. These are from a specimen out of Morocco. But the authors of this paper did these very high quality up close images. And so you can see in the left hand, that tooth is just coming straight out of the jaw. It is bone all the way through, and those pseudo teeth are firmly connected to the jaw. The other thing you would note on here is that there's lots of pits and grooves running along the length of these teeth. And those are for blood vessels that would have fed the overlying keratin sheath. And so keratin is a material that we have in our hair and our fingernails, but in birds, turtles, plenty of other things with beaks, they're as I said, their beaks are made of bone with this overlying keratinous material, and so these blood vessels would have helped provide the nutrients for that.
It even looks very similar to a horn.
It does.
So that you have the keratin covering over it, but you have that surface.
Exactly the same. Yeah. So just if you're thinking of cow horns, yeah, you've got the bone overlying with that keratin covering. So we bounce back to the Santa Barbara specimen, and here, we're just going to isolate just the one side of it. And if you're looking at this and still not convinced that this is a bird, you're not certain, the head from the tail, we can sort of break that down here with a side by side with the wandering albatross. Now, the image on the right hand side, this is the wandering albatross. This is the largest flying bird today, with a wingspan in the 11 to 12 foot range. So if you think of a tall male human at 6 feet, stack two guys on top of each other, and that's going to be 12 feet. So with this slab here, we can start to point out some of the features to make it a little bit more understandable as to what's going on. We can add in, this is where the eye and the beak are sitting. The humerus, or the upper arm bone, I have highlighted here in blue. In green, this is what's equivalent to the forearm. So you have the radius and ulna. In orange, we've got the wrist and digits. If you're a bird anatomist, you would say the carpometacarpus. So basically everything from the wrist and down. And then we also preserve the feet here in this slab. So this bird specimen in the slab on the left side of this image is fairly complete, although squish flat and crunched up. But to give a sense for the size, here you have a picture of, shamelessly promoting myself, talking with one of the museum curators, and you can see just, you assume that I'm a average human height. This gives you a sense for how big this bird can be. I think here I am pointing out the pseudo-teeth and just trying to explain how cool and crazy these things are. So yeah. So to put this in the context of time, I have just a generalized time scale here. You have the Cretaceous marked in green on the left-hand side, also marked with a big K. And then moving from the left to the right, you get closer and closer to the modern era. Right where the green transitions to orange, that's the KPG extinction. That's where all of the non-avian dinosaurs go completely extinct. And if we pop in the time period for that Santa Barbara bird, the rocks that this bird was encapsulated in date to between 10 and 16 million years ago. So we mark that here just with a block to sort of bracket that approximate time period. So these pelagornithids, they're found all over the world. This is an image from the paleobiology database to kind of show where these pelagornithids are coming from. And I recognize that with like yellow and orange dots, they may be a little hard to see. So just to point out some of these regions that we find pelagornithids, we've got both coasts of North America. We do have both coasts of South America, and in particular, I'll point out Chile that we'll talk about in a second. The Moroccan specimens, if you remember a few slides back where we got the close-up images of the pseudo-teeth, so we see these birds coming out of Morocco. And one of the birds that I'll talk about next comes from New Zealand, but we get these birds from other places that I didn't circle in here as well. Okay, so these birds span pretty much the entire globe. So to give us some context for pelagornithids broadly, I selected a few specimens to talk about here. To start, this is Protodontopteryx ruthae. This is the oldest pelagornithid. So similar to the Santa Barbara specimen, this bird was found in a slab of rocks. So you can see on the left-hand side of this image, just the bones are all kind of jumbled on top of each other. But in particular, what's called out on the right-hand side, we do see the jaws, and the authors here have denoted with arrows where some of these pseudo-teeth are. They're kind of small lumps at this point, but yeah, that's where they are. Yeah, so here we have just a headline from one of the local papers to New Zealand talking about this specimen. So this Protodontopteryx comes from rocks that are dated right around 62 million years of age. As I said, they're found in New Zealand, and this bird, and you can sort of see the reconstruction here on the right-hand side. This bird is estimated to have about a 1 meter wingspan, so something in the ballpark of 3 feet long. That's equivalent to our modern seagulls. So just to give you that frame of reference, these earliest pelagornithids are showing those pseudo-teeth, but they're very small in size. Nowhere near the giants that we'll be talking about in just a little bit. So we return to the timeline, and in this case, we plot where Protodontopteryx ruthae is located. So the thing that I want to point out, I think we sort of touched on this leading up to the start of the presentation, is that this group of birds, is firmly nestled within crown aves, so the modern birds. You know, these are birds that do not have teeth. The last toothed birds were from the Mesozoic, right before that KPG extinction on here. And shortly after that extinction, you know, maybe just 3 or 4 million years, we get this Protodontopteryx ruthae that's starting to show the signs of pseudo-teeth evolving. Okay. From the earliest Pelagornithid, we're going to take a very big jump forward in time and get to the biggest Pelagornithid. And that's where we can talk about Pelagornis sandersi. So Pelagornis sandersi was found in South Carolina, not too far away from Tennessee, at least from where I'm coming from in California. It's much closer to you all than it is to us here. And I put up this still image from a YouTube video that the Smithsonian put out, specific to Pelagornis sandersi. Again, showing, you know, your 6 foot tall person and how that kind of stacks up to what Pelagornis sandersi would have been. So here, just the body itself of this bird is estimated at 6 feet long. But the specimen itself, as shown here in the bottom right, has many well-preserved elements. And so the authors of this study estimate the total wingspan of this bird would have been in the 6.4 meter ballpark. So that puts it at 24 feet. So this would have been just a huge monster of a bird flying the skies.
And do you think, I mean, are all of these coastal birds, marine
Yes.
birds?
Yes. Yeah. They're all being found in marine sediments. And yeah, indications are definitely that they are sticking to the coasts.
Giant seagulls. So
Oh,
can imagine the problems we would have.
Yeah. I mean, they're, you know, for a long time, they were thought to be related to albatrosses, pelicans, because they share that body plan, that their wings have distinctive morphologies that indicate they would have had their wings out for soaring for long periods of time. So yeah, I mean, they'd be
carrying our kids off, wouldn't they?
Oh,
yeah.
Oh, easily. Yeah, and flying long distances across vast oceans. I mean, it's definitely a picture that I like to daydream about. Not taking kids away, but certainly flying those vast oceans. Yeah, we can jump over to Chile, and we have a specimen there named Pelagornis chilensis. This is again, just as we were talking about, coastal specimen, but from the southern hemisphere this time. And you know, this is a specimen that would have had about a 5 meter wingspan, so that's about 17 feet. And I really like this image here on the left-hand side. This is one of the authors of that study sitting next to the specimen laid out. And again, it helps to have this human frame of reference, but at least in my mind, I'm still boggled as to how big these birds are, because you know, something that we have to consider when we're looking at these fossils is that we're not even adding the feathers on top of it, which would have further elongated that wingspan. So this is an incredible specimen, and seeing David sitting next to this bird is still impressive, but I'm still having a hard time fathoming just how much bigger this bird would have been when it was alive. And as you can see here in the bottom right, the skull is just magnificently preserved, and you can see all the pseudo-teeth popping out of it. Yeah, I mean, this is such a great specimen. So we have Pelagornis sandersi and chilensis. These are representing some of our upper end of the Pelagornithids, and we can plot them against our time scale. Sander's eye coming in here towards the end of the Oligocene, somewhere like around 23 to 28 million years of age. And again, just to point out, this is that 24-foot wingspan bird. Chilensis, the one that we were just looking at, this one has a bit of a wider range, from 16 million to about 5 million years in age. And again, this is like that 5 meter, somewhere in the 17-foot wingspan kind of ballpark. So yeah, I think let me keep moving on to the next specimen I'd like to talk about. So here we have a map of California again, and you'll see with the yellow arrow, I'm pointing out Santa Cruz County. This is not too far removed from where I am right now at UC Berkeley. In Santa Cruz County, there was a partial humerus found from one of these Pelagornithids. And because it's a partial humerus, it could only be identified to Pelagornis, which is the genus, but it wasn't identifiable to a species. And since we're talking about the humerus in birds, I feel like this is a good place to kind of give a frame of reference. So this is a chicken humerus. If you've ever had hot wings, this is the drum. So if you're thinking about, I mean, if you're thinking about lunch, which I know in some parts of the country it's about lunchtime, think about hot wings. Think about how big one of those drums would be, and that's what you see here. Okay, so that's the start. We layer on top of that. This is an albatross humerus. So if you remember, I showed that picture of the wandering albatross. The wandering albatross is the biggest of all the albatrosses, with an 11-foot wingspan. This is probably a smaller individual, but still albatrosses get really big, as you can see, compared to that chicken drumette. Okay. Now we bring in the Santa Cruz specimen. That's what we're showing here in the dark brown. Again, that bone on the bottom of this screen, that's your hot wing. Okay. So you can see just how much bigger these birds are. And if you remember, I mentioned that this was a partial humerus. So shown on the right-hand side is the artist reconstruction of how much bigger this specimen would have been had it been complete. So if we're going to talk about incomplete specimens, I think it behooves us to take the albatross and the chicken and do some very crude photoshopping and remove half of those, so we could better get a sense for how big just half of one of these wing bones would have been.
So if you were going to order, an order of hot wings, how many would you get? I mean, would it just be like, I'll take a quarter?
I mean, I think if I were ordering Pelagornithid hot wings, I mean, I would be having a party and just get one. Yeah. Order one, and then you invite a bunch of friends over, and everybody just goes to town. Yeah, that's like that's Super Bowl kind of food, Super Bowl party. So we have this Pelagornis from Santa Cruz, known from just this one bone. This is and it just so happens that this specimen is also here in the University of California Museum of Paleontology, just where I happen to be. So it's handy for a guy like me who enjoys looking at these birds to get to look at the specimen, whenever I can. And just to point out that so the authors who wrote this up, they did do some estimations as to the wingspan of this bird, and this is in the same ballpark as what we saw in Pelagornis chilensis. So topping out about 17 feet wide for the wingspan. And so to plot this specimen onto our time scale, this one comes in as one of our youngest Pelagornithids, one of the last Pelagornithids known to date. There are some from Morocco that are dating to right about the same time, and so this is the end of the Pliocene that this group is. That's when they taper off and go extinct. So I just want to point out that of all the Pelagornithids that I've mapped here on our timescale, this does not represent all the Pelagornithids known. There are so many more, as I pointed out, that come from Europe, Japan, Western Asia, parts of Africa. There are so many more regions that I couldn't represent here because the talk would then go on for multiple hours. But what I can point out here with the ones that we have plotted, we've got the oldest on the left-hand side with Protodontopteryx, and with at least the Santa Cruz specimen, we've got one of the youngest. So this group of birds existed from about 62 million years to right around 2 million years of Earth history, which is a long time for this group to have been on planet Earth. And like I said, cruising the vast oceans, and then getting to large sizes, as we see here kind of in the middle of this timescale with Pelagornis sandersi. So to understand how we go from Protodontopteryx, which was that 3-foot wingspan, like seagull sized, to Pelagornis sandersi, which is that 24-foot wingspan, we have to look at the in-between space that's basically centered around the Eocene to find where these birds finally got to that giant size. And that's where my research team comes in. So as was mentioned, I'm at the University of California at Berkeley. We have the UC Museum of Paleontology, represented here in the bottom right by the T-Rex that stands guard in front of our entrance. And as I've been a PhD student here at Berkeley, one of our museum scientists, knowing that I did my master's on seabirds, that I was really fond of these Pelagornithids, she brought this specimen here on the left of this slide. She brought this to my attention. And I'll go on to explain what the specimen is in just a little bit. But to give some background, the specimen was found from Antarctica. So again, here we have that world map of Pelagornithids. And if you look at the very, very bottom, there's a little orange dot just off of the Antarctic Peninsula. And so here's a zoom in showing that the Antarctic Peninsula, and if you look in that tiny little box, there's a little tiny island that we have blown up here on the right-hand side. This is Seymour Island. Now, Seymour Island is, like I said, it's an island off the Antarctic Peninsula. Teams from UC Riverside had been going to Seymour Island and Antarctica for multiple years during the 1980s, collecting fossils. And in particular on Seymour Island, you get fossils from the Cretaceous all the way through the Eocene. And that's where that specimen was discovered. So you can see the numbers I have marked on Seymour Island in the orange. That's where other Pelagornithid material had been found. So those teams from UC Riverside collected these specimens along with plenty of other penguins, mammals, other fossils from Antarctica, brought them back to California, to Riverside, which is in Southern California. And in the early 2000s, that whole collection moved to Berkeley, where I get to play with them now. So that specimen, what I have shown here on the left, is a partial dentary. So dentary just being the jaw, the lower jaw bone. And as I said, it's partial. Here on the right-hand side, we've got, this is albatross. I think albatrosses make for a good point of reference, again, because they are the largest birds, largest flying birds today. But because this specimen on the left is just a fragment, it helps to point out just about how much of the albatross dentary this would represent. So the specimen on the left-hand side, this is about 12 centimeters. It's about 4 to 5 inches in length. And you can see my scale bar in the picture on the right, how much bigger that jaw would be if you tried to put it again, right next to this albatross skull. So if we just focus on the dentary here, one of the very nice things about this is it does preserve some of the pseudo-teeth, and I will admit that they are fairly worn, but I'll point them out here. We know that this specimen was sitting on the surface of Seymour Island for a long period of time. We don't know exactly how long. Long enough that the pseudo-teeth were eroded, weathered down. The specimen also has lichen in little patches growing on it. So this specimen had been on the surface for a long period of time. I can only imagine if those teams from UC Riverside, if they had shown up just a season or two earlier, how much more of this bird jaw there would have been. But let's, I can be thankful for what we have. We do have some of these pseudo-teeth, and it's the size and the spacing of the pseudo-teeth, as well as just the overall dimensions of the jaw, that allow us to make some comparisons. So, we take these measurements of the height of the teeth, the width of the teeth, the spacing between the teeth, again, measurements from the jaw, and based on all of that, we really can say that the bird that this dentary fragment came from would have been on par with those two big birds that I pointed out earlier. So Pelagornis sandersi, Pelagornis chilensis. So, that puts our bird squarely in the, 17 foot is what chilensis is, and 24 foot is what sandersi was. So our bird, if you split the difference, it was in that 20-foot ballpark. Okay. So even with a scrappy specimen, as some people would describe this, you can still extrapolate a lot of information from it. So that was my gateway into Antarctic pelagornithids, but it certainly wasn't the end of the research, because we have other pelagornithid specimens from Antarctica housed in the UCMP. And this here in the center of this slide is a tarsometatarsus. This is just an ankle or foot bone. Again, on the left-hand side, you've got a similar bone from an albatross for reference. So this specimen, this was collected by Jeff Stillwell, who was associated with the UC Riverside team. And again, we compared this to other tarsometatarsi from other pelagornithids, and it has been known that this specimen is the largest tarsometatarsus of all the pelagornithid specimens around the world through the entire span of that, basically the whole Cenozoic. But the interesting thing with this specimen was that in previous papers, it was incorrectly reported to a younger age. So it was originally thrown in up here, what I've got marked out with the blue arrow in these younger rocks towards the top of the right-hand strat column. This is actually where the dentary comes from. We have other giant material from these higher rocks, as well as some average size pelagornithid material. But by looking into the original field notes from that team from UC Riverside, when they collected in the 80s, they took all these field notes about the geology, about the specimens they were collecting. I went into those old notes, looked at them, and it turns out that this tarsometatarsus actually comes from this lower unit that we see on Seymour Island. This is a unit that up until this point was only represented by, still large Pelagornithids, something in like the 15-foot wingspan, but no giants. And by just doing some detective work, finding that this Tarsimetatarsus comes from an older period, we start painting this picture that Pelagornithids in the Eocene of Antarctica were represented by multiple different size classes. So you have giants as well as large, subgiant. You've got them flying around all at the same time, coexisting. So we return to our timeline, we fill in this middle period with our Antarctic specimens. And I do want to point out that the Eocene is represented in other parts of the world by Pelagornithids of various size, but it's here in Antarctica that we certainly see the giants start to pop up here. So early Eocene, that's where the giants are popping up with that Tarsimetatarsus, and they're spanning the whole of the Eocene with that dentary that I pointed out, and then they're off to the races with Sandersi and Chilensis. And so wrapping things up here, I just want to point out this is our wonderful art reconstruction from Brian Chu that we had commissioned just for the paper that came out in October. And I think this bird, being found in Antarctica to traveling to California, making its way into collections, and then being depicted here in art and certainly all the media coverage. I think this bird has flown around the world multiple times as a way to think about how much this thing has traveled. And so with that, I just want to acknowledge the various museums that I've been able to travel to that have allowed me into their collections, multiple people that I've talked research with, my lab mates who've heard me talk about toothy birds for far too long, and then my various funding sources, some for myself, and then one of my colleagues was funded by a National Science Foundation of China grant. And with that, I'm open to taking questions.
Such cool work. Thank you.
Yeah, you're welcome.
David, if you can jump in, and Chris too, with some questions.
Should I unshare my screen?
You can leave it, and that
Okay.
way, if anybody has any questions about the images, we can go to that.
Yeah, we've got a bunch of questions coming in from the audience. So quick reminder, if you have questions and you are the audience, go ahead and leave as a comment in the Facebook comment section. Or if you can't do that, go over to the Great Fossil Site Twitter and Instagram and leave a question there. I'm going to start with this question from Grant, who asks, what do you imagine pushed the evolution of the pseudo-teeth?
Yeah, that's it's such a great question, and I honestly don't know. I mean, so a thought that I've had is, the fact that these birds come about so relatively shortly after the KPG extinction, that we just have these niches that have become open. So not only the loss of non-avian dinosaurs, but also pterosaurs, as well as large marine reptiles. So we have space in the sky that's open for large flyers, as well as just productive marine waters that could help drive food sources. So yeah, I mean, I don't know exactly what's driving the pseudo-teeth, but I think there's certainly environments that are friendly to getting big and fishing things out of the water for food. Yeah.
All right. Well, that it seems to get at the answer to another question by Jenny, who was asking what triggered the rapid growth in the body size. But Chris, it sounds like you have a question.
No, go ahead and answer that one. I'll piggyback in when I can.
Oh, well, I mean, yeah, as far as giant size, yeah, I think it was just a lack of competition, at least in the skies. So one thing I will just point out is so that these birds are certainly some of the largest birds ever to fly. There are now oh boy, I'm blanking at the name, but there's something from the Pleistocene, something a little bit closer to vultures.
Argentavis.
Yeah, Argentavis. Thank you. That would have competed for large flying birds, but they don't show up till much later, and they would have had very little, if any, overlap with the end of these pelagornithids. So for the bulk of their existence, they just didn't have competition in the air, and I think that's probably what allowed them to get so big.
Well, yeah, as a person who tries to wrap his brain around terrestrial mammals all the time, the idea of not having enough space in the sky is really kind of mind blowing. So driving evolution that way. The one part of this also comes back to, are there performance characteristics in these bony teeth? How that are they different than normal teeth? Are they different than bills? I mean, what is really driving? I mean, maybe not driving the evolution of, but what do they do better than other things?
This is a question that I've been asking myself just about beaks broadly, not just the pseudo-teeth in these birds. I mean, one of the really handy things about keratinous coverings and beaks is that they're constantly regrowing. If you break a tooth, as a like a carnivorous mammal, like if you break one of your canines, you're stuck. You got to find other ways to fend for yourself. If you wear down the keratin on one of your pseudo teeth, you wait a little bit, just like your fingernails keep growing, that covering will replenish itself. So in some ways, I mean, maybe I'm just now putting this thought together. Like cats, cats that are constantly removing parts of their fingernails to get that sharpened edge. I mean, maybe that's an approach that these pelagornithids are taking, is that by having a keratinous covering, they're constantly able to have a sharpened point for spearing fish or squid, the presumed prey that they would have been eating. That's a very first, just quick thought to answer to that one.
So on that topic, we just got a question from Greg McDonald, who asks, any idea what type of fish they ate? Are there any specimens with gut contents?
Oh, so unfortunately we don't have any gut contents yet. Hope, I can hope that maybe a future specimen will change that. I don't think we in the literature, I don't think it's been hypothesized what sort of fish exactly they've been eating. So yeah, I don't know.
I think there's another question. Oh, sorry. Go ahead, David.
I was just going to say, Greg also asked, are the largest pseudo-teeth always in the same position, or do they have different positions in different taxa?
So funny thing with the pseudo-teeth that I didn't even get to touch on is that they have a regularly spaced pattern to them, but the placement of those largest ones isn't regular. So let me, if it's okay, I'll dial back to one of my slides. Actually, there we go. So you can see in the left-hand side with Chilensis and Sanders' eye, you get this regularly spaced pattern of basically, big tooth with some smaller teeth in between, then another big tooth and some small teeth in between. And this is a pattern that had been observed all the way back to Hildegard Howard in 1957. She observed that. And actually, now that I think about it, probably even before that with Richard Owen in the mid 1800s. Yeah, I think he was the first to name one of these pelagornithids. So the exact placement is not the same, but the patterning is fairly consistent. There you get a couple deviations from the pattern, but they stay fairly consistent across the entire group.
See, we had a question as well about the weight potential of what they're capturing. So how large of something could they actually get and then fly again? And a related question that I have, that one was from Donna, but in a related one that I have is, are they going down and hitting the water and fishing? And then how in the world are they getting back out of that again with gravity playing?
Okay, so this is everybody in the audience is touching on all these questions that I have been grappling with, and I don't have the answer. I want to work on this so bad, but yes, the notion of, are these birds skimming the water just to maintain flight and then kind of getting out of Dodge while they got something in their mouth, is a possibility. I know I've talked to other folks who propose that they maybe are landing in the water, maybe doing some dabbling, and then either with like a running water launch, or maybe just slapping their wings down to get themselves up out of the water. There's lots of hypotheses, and man, I wish I had the answers.
I think Donna
just don't.
basically wanted to know whether or not a petite woman like herself, she said, could be taken and eaten by one of these.
I honestly don't know how.
We'll just say yes.
Yeah.
Yes, make it. Yeah.
It's possible.
All right, we've got another one here about relationship. So Gino asks, are Pelagornithids closely related to Gallo-anseres, the landfowl and waterfowl? And I'll add to that, if not, where do they fall?
Yeah, so the phylogeny of this group is still being worked on. As I think I had mentioned it earlier, that originally they were thought to be closely related to albatrosses and pelicans. And that was strictly off of just the body plan. Again, that their wings being built for holding them out for long periods of time and soaring. I'm trying to think how recent we're talking. Since the early 2000s, current thought is that they are related to Gallo-anseres, which is the group that includes chickens, ducks. But where exactly they're in, that's where it's still up for debate, whether they are more closely related to ducks or, further outside of that, just with Gallo-anseres. Is it just neonates broadly, which is all birds except for like your ostriches and rheas. So yeah, I honestly, I don't have the exact answer, but I know folks are working on it, and the current thought is Gallo-anseres, as your question asker had put it.
All right, here's another question that is probably going to inspire you to say, I wish I knew the answer to that.
Oh no.
Mason asks, are different size classes occupying different niches or eating different things?
Yep, that's a question I wish I knew. I mean, that's certainly what we're seeing in Antarctica, the fact that we've got these two different size classes occupying the same area at the same time, it leads me to believe that there's some partitioning going on. I haven't had a chance to look into it more, and I know that's not the only place that you get overlap in size classes. I'm drawing a blank exactly where, but I think we do see multiple size groups in other places of the globe at other times. So yeah, it's probably happening in Antarctica and probably happening elsewhere. But yeah, I need more time to look at these things.
We'll have to have you back on in a few years.
Sure, yeah.
Andre asks, what are possible drivers of the extinction of this marvelous clade?
Another fascinating question that we need more people working on these things to figure this out. And I mean, in some ways, I think this can kind of loop back to my master's, that at least with coastal California in the period of time that I was looking at, which kind of gets at that roughly same time period as the end of the Pelagornithids, we see a lot of tectonic changes. resulting in changes in upwelling, and certainly there's climatic drivers that are happening. We're at the end of the Pliocene, we're leading into the Pleistocene. Cooling had been happening before that, but certainly the thermostat is taking a deep dive in that transition from plio to pleisto. And so maybe there's some aspect of that, the changing climate and changing tectonics that these pelagornithids just aren't suited for. And maybe that's what's driving it. That's my best guess.
All right. So we've got a couple other questions that we can get through real quick.
Yeah.
Charlie asks, no, this one's a question about you, not about the birds. So there's no wrong answer here. Charlie asks, what was your experience like working as a paleo monitor for so long? And how do you like it compared to academia?
Yeah, I mean, wow, that's a great question. So I did paleo monitoring for about 7 years. And I think it was a great opportunity to see a lot of the country and look for fossils, which, as a kid playing in the dirt, that was heaven. Just finding fossils was great. I had a great experience and worked with a lot of good people. I think for me, and the curious side of my nature, it got to be a little tough towards the end because, like I was saying, I had all these questions and couldn't, we didn't have the time to answer them under our various contracts. And so that was a really hard thing for me to grapple with. And going back to school is what allowed me to explore those questions. And you can see, like, there's so many more questions just with this group, let alone all of paleontology, that I think it would be very hard for me to go back, but I leave the door open. It's possible.
All right, we've got one more audience question, and then I've got a question I'd like to ask. Grant asks very simply, isotopes?
Yeah, isotopes, question mark.
So Grant always likes to be the one to ask if any isotopic work has been done on these specimens.
And to the best of my knowledge, I don't believe so. There's a lot of microscopic studies that could be done that I have in mind. And exploring isotope signatures is certainly one of them. But that's definitely a skill set like I would need to pick up or start forming some new collegial relationships to explore that. So Grant, you could send me an email.
There you go, making connections.
Yeah.
All right, and then I've got a question I'd like to ask.
Yeah.
These birds are super cool. They're weird. They're gigantic. They have teeth, and they're very eye-catching and exciting. And there is this trend in paleontology where big, intimidating, interesting, cool things get a lot of the attention, right? The dinosaur situation.
Sure.
And it always makes me wonder, what's being overshadowed by these big, cool birds? Are there interesting organisms that we find at the same fossil sites as these birds that were living in their ecosystem that maybe don't get quite as much attention as the big, cool, toothy birds?
So very, very astute observation in terms of all those superlatives that we come up with: biggest, oldest, youngest, even. I think there could be some things being overlooked. Just with the collections we've got here in the UC Museum of Paleontology, there are tons of penguins. And I know a lot of people think, oh, penguins, Antarctica. Well, duh, of course they're there. But the number of fossil specimens that we've got, I'm sure there's going to be some interesting penguins just to begin with, but then because you've got the volume, you could do more population level studies. So, I mean, just in penguins, I think there's interesting questions to be had from this part of the world in this time period. I I think there's also mammal specimens that, may be getting overlooked. A really cool specimen that I don't know where it's housed, but it was written early in 2020, so at least a year ago. There's a frog. The first Antarctic frog was found in these similar sediments. So Eocene in age, Antarctica, an amphibian, which really tells you about the climate of that time and place. So there's, this whole Eocene Seymour Island is just ripe with questions of all flavors. And yeah, we just need more people to work on it.
Very cool. Well, hopefully we'll see more work going on down there in the future.
Yeah, I mean, I would love to actually go to Seymour Island and dig for myself. We'll see if I can make that happen or not.
All right. Well, I think that's the time we have for audience questions. Blaine, I'll turn it back to you if there's anything else you want to say.
I have about 20 more questions, Peter, but if you can stick around a little bit longer,
Sure.
We can chat, but we better end the show there. And Thanks everybody for joining us. And thanks again, Peter. That was really enlightening.
I mean, thank you very much to you all as the host for bringing me on board, and to the audience out there for the enthusiasm and listening to the talk. Thank you.
Our pleasure. Bye-bye.
Thanks, everybody.